We talked about the Carnot efficiency in class for a heat engine cycle. And I'm defining it here again. It is defined in terms of the lowest and the highest temperature in the cycle. In the case, the lowest temperature, if you look at the table on the left, is 45.81 degrees C. The highest is easy to see, 600 degrees C. All we need to do is then plug in the numbers, making sure though, when you're plugging it in, your temperature must be in Kelvin. For a cycle's thermal efficiency, for a heat engine cycle, the thermal efficiency is defined as W dot net over Q dot in, where W dot net is defined as the net work done by the turbine. I'm going to put in an absolute value just to ensure that you don't make a mistake, minus the work done by the pump. Because many of you are always confused in terms of what is positive and what's negative. This will make sure that the confusion won't happen. Notice that these are capital letters. That means that we need to take into consideration of the mass flow rate, which I'm going to re-enter in a minute. And my Q dot in, obviously in this case, is going to equal to the Q into the boiler times its flow rate. Okay? So let's see how we can do that. Before we do that, let's go ahead and pop in the mass flow rate. 1 minus y, we've done that before. 1 minus y. Number 2 is also 1 minus y, 1, 1. So we are now ready to determine. So the work turbine is going to equal to the mass flow rate of 6 times the work into the first stage of the turbine. So mass flow rate of 6 is y times work. You can get these numbers from the prior slide. Plus 1 minus y, and the work from 5 to 7, which we calculated during the part 2, I believe, of the video. This is of the pump. For pump 1, the mass flow rate is 1 minus y, 1 to 2. And for pump 2, the mass flow rate is 1, 3 to 4. We have those numbers from part 3, I believe, of the video. And Q in is equal to the mass flow rate through the boiler, which is mass flow rate at 4, that's equal to 1. And Q from 4 to 5. You have these numbers, which I'm going to put check under them. Hopefully a side on a piece of paper taken from the prior videos. And at this particular point, you can then plug them in. Your final answer will be in terms of y, since we did not tell you what y is. But this is how you figure out the cycle's thermal efficiency. It's by this particular equation right here.